All right, ladies and gentlemen, I want to thank you for attending. This is the Nickel and GSI, let's get the right, Nickel and GSI Language and Performance Improvements in Couchbase 5.0 and 5.5. I'd like to introduce Keshav Murthy. He's our Senior Director for Nickel, part of our Couchbase engineering group, who is our expert. He's our go-to guy whenever we have something Nickel related. We're looking to find out how we can make something go faster and do a little bit better. So you've got probably the best of the best here for Nickel. So I'm just going to turn it over to you. Just a couple of house cleaning. We are going to try and hold Q&A until the end of the presentation. So if you got your pens, you can write down your questions down so we can make sure we get everybody through the topics. We have a very tight time frame. So as this ends at 11:45, there'll be new people coming in and you'll be going to your next session. So I'll try and keep everybody on track as we go forward. So Keshav, take it away.
Thank you, Art. Let's get started. So just so that we won't leave anybody behind, I'll cover Nickel for newbies in the first 5 minutes, and then go through the features in Nickel and GSI in our Couchbase 5.0 release that was released in October 2017, and Couchbase 5.5 features that's in beta now and going to be J in a couple of months. Let's get started. What is SQL? What does SQL as a language and engine do? It takes sets of relations as input, does the processing based on select, insert, update, delete statements, and then gives you the new result set. Sets of flat relations gives you one relation as output. What do you do to achieve the same effect in a typical NoSQL database? In a document-oriented databases, you give sets of JSON as input, and you have to write a report or achieve some task. You use the NoSQL API to fetch or set the data. And then you develop this application data logic to actually do the processing of the JSON documents, right? See, this is not declarative, right? SQL is declarative. You just write what has to be done, and SQL engine figures out how to implement it. But in NoSQL, you have to write all this application logic to achieve the same task you did in SQL, right? For example, find high-value customers with orders greater than $10,000. Right? So this is not an easy language, easy task to do if you have to write in an API-based NoSQL database. You had to fetch all the documents, find out the orders, group the orders by the customer, add them up, and you have to implement all the group by logic, aggregation logic yourself before you finally filter out if the sum is greater than 10,000 and then produce the report, right? This requires you to write a lot of complex logic, and it's inefficient. What Nickel has done is to give you the same facility that SQL provided for relational systems. Input is sets of JSON. You process according to the Nickel query you have written, and gives you the result in JSON, right? JSON in, JSON out, right? There is no loss of information or the structure, right? The goal of Nickel, right, which is SQL for JSON, is to give developers and enterprises an expressive, powerful, and a complete language, not just select. We have select, insert, update, delete, merge, infer, for querying, transforming, and manipulating complete JSON data. That's the goal. So the analogy I use is, even if you have a powerful engine, if you can't manipulate it, it's very difficult to drive the system, right? So with SQL, you had your steering wheel. Now with Nickel, you have your steering wheel. You don't tune the engine. You just say where the data should go, how the data should get manipulated, and it gives you the results back. Let's look at JSON data types. JSON itself has got numbers, strings, booleans, null, arrays, objects, and the beauty of it is you have you can have arrays of objects, objects of arrays, arrays of arrays, and so forth. That gives you the flexibility, right? In terms of Nickel declarative statements, you get the select, update, delete, insert, merge. How many of you know SQL to any extent? Right? Almost every one of you. So these things should be very, very familiar. This looks like SQL. This works like SQL, acts like SQL. It's very close to SQL, except we have extended the SQL semantics to work on JSON data model. Let's look at some examples. Select, you have the projection list. Star means the same thing, project everything from the bucket. You have filters right here, and you have the sort order specified by the order by. It just at the simplest form, it's the same thing. Let's look at some of the basic extensions that we have done. In terms of, in JSON, you have the nested form. All the references are through dotted expressions. So you have a.b.c. That's the way to address elements at every level. We have introduced the unnest operator, which I'll talk about that later on to help you manipulate arrays. And then, yeah, and rest of it is pretty familiar. So in terms of SQL joins, we support inner join, left outer join, and right outer join. We have introduced these joins in standard ANSI join semantics in 5.5. Previously, we supported the equi-joins on the with the parent-to-child relationship. We have aggregations, the standard aggregations, which I'll talk about the huge improvement that we have done in 5.5. And all the set operators, union, union all, intersect, intersect all, except all, they are supported as well. Our underlying data store is a distributed data store partitioned via hash keys. So we have extended the language to include the use keys. Whenever you know the document key, you can directly get to it from Nickel. Yeah, join on key, I talked about the inner, left outer, and right outer joins. In terms of the implementation, we also implemented the hash joins to improve the performance when you have large number of documents involved. Unnest and nest. When you have arrays within a JSON document, to process that as a flat relation, you can simply unnest them. I'll show you an example in a moment. Unnest operator helps you to flatten the arrays, and nest does the opposite of it. Any kind of joins, nest, and unnest can be chained in any combination. Here's an example of unnest. Here is a customer document with 2 billing information, and I take the customer document, unnest the billing as B, and in the projection, projected, you still have customer accessible to you, as well as the unnested b.type and card number. So this one document, when you unnest, because the billing has 2 billing objects, you get 2 documents out. You get the original document as well that I have projected, as well as the b.type, the first b.type and the type and the card information, second card information that I have highlighted in the right side. That's as simple as the operation gets. Okay, so unnest was a simple operation on arrays. So when you have arrays and objects, you need language extensions to operate, to filter, to operate on the nested representation of data in JSON. That's what we have done. You can range over collections with any and every predicate. You can create arrays with the array expression. You can do deep traversal of the JSON using within clause. You can construct JSON. JSON is a first class literal within literal and an object within query language. You can construct any kind of JSON in anywhere an expression is allowed, whether it's projection or the predicate or a aggregation. JSON is a first class citizen. So nested traversal I talked about, and to introspect if a key attribute exists or not, you can use the missing, not missing predicate. Okay. Architecture. You can deploy Couchbase in a single node or a cluster. Typically, for production, you deploy in a cluster. So let's double click on this. You can deploy the query service together with other services or separately as a standalone service within your cluster, and query orchestrates the execution of the query using the other services. Let's look at the orchestration. Clients issue a query over REST API. REST API is the lower layer. You typically issue the query with CPQ shell or your workbench, or in your application any of the Java, Python SDKs. Query services does the parsing analysis and creates an execution plan, and then uses the index services to scan the index. If you have selected an index or two, we have used the index service to do the scanning and filtering, and then if necessary, if the query is not completely covered by the index, we go to the data service, get the rest of the documents, and execute them. So here is the inside look of the query service. If you have studied any of the database systems, how it works, this is pretty similar to that, except this executes in a distributed platform. Of course, that was a very quick overview. We have written the gory details of how this executes, how to model this, how to write the queries, etc. in our Nickel Practical Guide book. So the book should be available for you to pick up in the Nickel booth outside. You can pick up and read them. We have like 20 plus articles that deep dive into this. And you learn better by doing it. We have the query tutorial, online tutorial, where you can play with Nickel without having to download or install anything. So check that out. So we actually released the first version of Nickel in 4.0 back here in 2015. So from then, we have continuously improved our feature, functionality, and performance. I'm going to focus on 5.0 and 5.5 features. So let's get to it. But overall, what does it mean when we have added all this SQL-based query language to JSON? How does it compare with the standard SQL, right? This is a kind of a one slide cheat sheet for you to compare and contrast. This should be available. So, obviously, you can't read everything. I won't go through everything in this talk, but this slide deck should be available for you to download shortly. And just so that it makes it easier for a lot of the newbies to Couchbase to understand and learn Couchbase, we have just announced a new online course called Introduction to Couchbase for Oracle Experts. It applies to SQL Server. We'll have a customized SQL Server version pretty shortly. But there's an online training that people can pick up, have the mind map between Oracle to Couchbase in about 90 minutes. OK, so let's get to the 5.0 features. So I have categorized the high-level features into query and indexing features, the features that where the query engine exploits the improvements in the indexing, the query optimizer features that we have improved within the query optimizer, the core performance features, some of the language extension, as well as security and functionality. This usually takes 3 hours. I'll have to cover it in 15 minutes. Again, in the second edition of the book, we have written about all these features in detail for you. The first improvement is we have added the correlation for each of the keys within the index. Right? When you had to sort the index keys in ascending and descending order, you had to trick around at least the numerical values. You can have a negative expression on the keys, but you had to write the queries in a funny way so that we can exploit the indexes appropriately. It's not the main purpose of this is to improve the performance of the pagination features, right? When you have a lot of the interactive applications and you say, I want the results in order by of certain keys, and then you usually want the top 50 documents, or offset 50 top 50, whereas if you have indexes with the right correlation, ascending, descending, and that matches your correlation of your order by clause, index already has the data in that order, and we can get the relevant rows back to you with a much better performance, usually orders of magnitude better performance. Second thing, our indexing had a limitation of the maximum key size to be 4096. Having a lean mean index is always advisable, but in flexible schema, you can't control the changing of the document. It's a schema on read, not schema on write, so we can't enforce the size during the writes. So here, if you have the document, you can have the key size could be up to 20 megabytes, which is the maximum size of the document. So you don't have to worry about the maximum size of a index. Index replicas. Prior to 5.0, if you had to create multiple indexes, you wanted index availability both for scalability as well as HA. You had to create these indexes with different names manually. So in 5.0, you simply specify the number of replicas. That's the number of replicas in addition to the main index, and then voila, you got everything in place. And you can change that number of replicas dynamically as well. Indexing has introduced a new storage engine called Plasma. Basically, this is the memory optimized index that can go beyond the size of your memory. Right? If your memory can only hold up to, let's say, 32 gigs, and your indexing size, single index happens to be 100 gigabytes, that's no problem. Right? We do the standard LRU, MRU buffer pool management by fetching only the relevant data to the memory. So we handle that automatically for you. Just choose the standard secondary index in your enterprise edition. This is available only in the enterprise edition, and whenever you create an index, it simply uses it. There is nothing else for you to do. Okay, now let's look at some of the language infrastructure. So we had the simple subqueries in the from clause. What we have done is extended that to be a full expression. So in this example, so in the from clause, instead of a simple bucket or a key space, you can give an arbitrary expression, and result of all this expression is a JSON. And then once you have JSON, that's the input source to the subsequent query processing. Right? This gives you the flexibility. I'll show you the example using curl in a moment. But the reason we extended the language was in JSON, you have to sometimes manipulate the JSON to modulate the data to get in the form that you want for the query. You have to do kind of ATL within your query itself. This helps you to do that and write the queries easily. You don't have to transform, save it in a temporary file, and process it. This avoids the hassle of having to save and retrieve back. You can do all this processing in a single statement. Second thing, yes, one criticism of JSON is it has the basic data types, but not date, time, and timestamp functions. Right? Without this data type, you don't have an enterprise application. So what we support is the ISO, extended ISO format, but then we have added at least 100 different scalar functions to convert, to basically extract, convert, manipulate the date and date time, and with time zone, so that no matter which time zone you are, which part of the date time that you want to extract, you have it right there. And actually, we have done a detailed comparison of these functions and functionality between Oracle and Couchbase. I think we have covered all the bases. If you have an issue with this, please let us know. Did I skip something? Okay. Next one. Yeah, I mentioned about curl. Okay. In relational databases, whether you have the source of the data as a table or a function or a table function, you had to declare everything ahead of time, so you know the schema and the type of the data that is returning. Having flexibility in the data model as well as query processing means you don't need to know ahead of time what data is getting returned. So even within the enterprises, you have microservices that return JSON. They have REST endpoints and JSON. And there are several public services like Google and Amazon and Microsoft. They have public services that are JSON endpoints as well. I'll show you the example in a moment. What we have done is, within Couchbase, you can invoke any JSON endpoint in the world securely, right? Securely, so that you can get the results back. Example. Here, I'm trying to search for a place called Santa Cruz in the country of Spain, and I'm trying to get the location information using the Google API, right? It's a pretty straightforward query right there. I make a call to Google API, it returns the JSON, and I got the whole JSON. That's pretty simple, right? Second thing is, sometimes you have data stored within Couchbase, and you want to use that as a parameter to a REST endpoint externally. So in here, I have hotel reviews stored in travel sample, and I want to convert that from English to French or some other language that the Google translation supports. So this is a simple example where I have in the from clause, I have a subselect statement that invokes curl and does the French translation as well. Actually, when I tested French, I presume it was decent, but I don't know French much. I had it translate to my mother tongue. The translation was pretty decent, I would say. Yeah. So this is how we do it. So from the apps, you simply issue the curl, and you can and the Nickel service invokes the respective curl language. So you do have to enable this curl facility within query language, because security is paramount. It's turned off by default. You can enable it only for certain sites. All that you have to grant the permission to the user. So security is taken care of very well. Okay, so a lot of the simple functions in terms of bitwise manipulation. We added all the bit logical operations in 5.0. Okay, query optimizer. So we talked about some of the optimizations that we have done for ascending, descending. Here we have previously, when we requested the index scans, we used to send this composite key request separately. Now we have optimized this so that there are less false positives from the index scans to the query, so the performance better, and you also get the scans on a single index snapshot. So remember, our GSI index is eventually consistent. So, and we do the scans on snapshots so that the writers won't block the readers. So this helps with that. Yeah. So, and second improvement is because there is less to exchange from the indexer to the query, the performance has improved as well with less false positives from the index to the query. Okay, so we spent a lot of time in optimizing so-called the pagination queries. Pagination queries are when you use query with a offset and limit, and usually this offset and limit has an order by as well, right? Because you want the result in certain order, and if you have the right index, we push not only the predicates to the index scans, those filters to the index scan, but also since the index is organized according to the order that we want, we push the limit and the offset as well. So index only returns the data you want. The idea of all this is, Nickel is designed to help you develop interactive applications. These interactive applications make heavy use of pagination queries. So when you use this so-called the offset pagination, we have optimized this optimize the query optimizer. We have optimized the query optimizer to select the right index, push the right predicates, and as the pagination requirements as well. Yeah, we do when you have the right keys with the ascending and descending order, we push the min and the max to the index scan, so that's a quick lookup. Yeah, the third thing is prior to 5.0, let's say you had an index with 10 keys, and your query only had two filters on 2 keys and projected 3 more keys from the index. Your query is only interested in the 5 keys that you used, but index would return all the 10 keys whether you required or not. So we have implemented something called index projection, which will only return what you want. Here is an example of an index and queries. So this kind of internal detail, but what it does is you minimize the amount of data transfer from the index to the query. That improves your performance, throughput, garbage collection performance, and so forth. Cache and expiration, the TTL value, right? So you can index those values as well as get them from the index. So this is available only when you have queries that are covered. So we still have things to do in terms of getting directly from the data service, but it is available to the index service. So when you have this cache and TTL, or the expiration field within the meta function indexed, it's available for you as well. When you have the count distinct and the query is covered, we use something called the count distinct scan and get it directly. Again, the idea of all the optimizers, right? There's one goal that the optimizer engineers think, right? This has not changed in whatever 30, 40 years. Do less work, right? Do less work in the indexer, do less work in the query, right? So all this optimization is to just do less work. When you do less work, your performance improves. Your latency decreases, the throughput increases, all desired scenarios. Okay, last feature in 5.0, we had a customer who had hundreds of fields. They didn't know which ones the customer would ask for. You could take the typical queries and try to create composite indexes, but when you have queries that are generated dynamically, you don't know which keys are going to be queried or filtered, because index selection is essentially based on filters. So for that, if you have to create all different types of indexes, for 50 keys, 50 factorial comes out to be, I don't know what is. This is zettabytes. There may or may not. This is basically. Let me just say it's a huge number, right? So I don't think we can buy a cluster to fit all that. So the answer is having intersection, right? So you create index on individual fields, and the optimizer again does parallel scans of these indexes, does the intersection according to the predicates that you have given, and gets you the result. We have gone a step further to create something called adaptive index, where you can create indexes on all these fields. So no matter what key is used in the filter, we use this index. And more importantly, if you see the explain here, we push down the right predicates to the index scan, so only the data that you want is selected from the index, so your results is efficient. Is this a silver bullet for all your performance issues? No. When you know the queries that developers are developing, the composite index is still significantly better performant. But when you don't know what queries people are going to write, you have a range of keys that you want to index on. This is flexible, and it's better than the primary, way better than the primary key, obviously. Try this out, give us feedback. We have had a number of customers who have had success when they want this flexibility. Okay. Grant revoke, I know everybody loves security features. This works like standard grant revoke with the roles. Okay. So in 5.0, we have added humongous amount of work in monitoring and profiling infrastructure. That means when you get this for free in your enterprise workbench, when you're running the workload, we automatically save the expensive queries. You can see what are the active queries that are going on, but also we saved about 4,000 of the expensive queries that takes longer than, I think by default, 500 milliseconds. So you can go and see what queries are running slow, why they are running slow, and so forth. We also added visual explain. So the coloring has actually even improved in 5.5, which I'll show you in a moment. The filtering, the expensive portions of the explain plan tend to be darker, kind of brownish. Yellowish is green is good, yellowish is okay, reddish, brownish is are the bottlenecks. So yeah, we have done a lot in profiling and so forth. So we'll come to this in a moment. Yeah, a lot of improvement performance. I won't go into this into detail. Okay, let's skip over to 5.5. Come on in. Okay. No. So the big features in 5.5 is ANSI joins and group by and aggregation performance, index partitioning. So let's skip. I'll cover the first few features, and as Scott said, the gory details are in this book. Please pick up the book. I'll cover whatever is possible in the next few minutes. Okay. Couchbase Nickel has always had support for joins, but we only had joins with the parent to child, child to parent relationship that had to be equi-joins, and that's sometimes is a problem. You can't model your data like that all the time. So we have removed that restriction, right? We support the standard ANSI join syntax with the standard on clause. You can join any key to any key. We support the inner join, left outer join, right outer joins, and then in the on clause, you can give any complex expression that you need. You need on the right hand side of the inner join, you need an index on one of the fields at least. So that because we use a nested loop join, you don't want to be doing the nested full primary scan on the inner side of the nested loop. You need the index on it. It will tell you, if you don't have an index, it will tell you it doesn't have an index. You just create it and go with it. So basically, this looks, feels, works like the standard ANSI join. Okay, like I said, we support the inner left outer, right outer now. You can compose. This is highly composable. You can have any number of inner join, left outer joins, as well as nest and unnest, left nest, right unnest. All this combination there. Yeah, join order is still left to right. Right. We don't reorder. So make sure you do the write the from clause carefully enough so your results don't bloat up. And I'll talk about the hash joins in a moment. Before that, okay. Yes, we implemented ANSI joins, but JSON has arrays and objects. What do you do when you have to do joins based on the array predicate? We have extended the ANSI join semantics to support joins with array predicates. So here is the example of arrays. So you can have array when you have the on expression. You can have arrays just on the right hand side or on the left hand side, or you can have arrays on both sides. Here's an example. So you have product doing an inner join with purchase, and purchase.line items is array. So when you have that, we have the standard any expression. You can have any expression on any L in pu.line item satisfies pu.product ID equals p.product ID, right? There's array on one side. Similar, okay, when you have array on the other side, you can first unnest and then do the simple join, or you can have a array predicate right there as well. Okay, let me quickly move over. So far, so good. In terms of the implementation, we do the block nested loop join. It performs very well when you have hundreds of documents qualified and you want the first 10 values. It works reasonably good. But when you have thousands of documents that are getting joined, in this case, for example, so it takes about 5 seconds, right? So we have implemented a new type of join called hash join, which you have to specify the directive because we have rule-based optimizer. Use hash whether something is a probe or a build side. So we use the hash join that improves the performance by almost an order of magnitude, right? So in this case, hash is nested loop. We take one document on the outer side and do the lookup on the inner join. You go back and forth. In hash join, we scan the items on the right-hand side and get to the build the hash table and then get to the do the probing on the other side. So it's much faster. But we do have to build the hash table so that so that's kind of increases the lower limit on the query performance. Okay, this is the hash join. So this is the performance improvement. You see, as the number of initially when you have a few hundreds of documents, the nested loop is good, but as the number of documents increase, hash performance is much better. I may have to skip Q&A. I'll be around if you want to have any questions, but I will cover this another important feature that we have here. So in any query language, joins, grouping, and aggregations are some of the most expensive parts of query processing. Right? We handle joins, ANSI joins, hash joins. In terms of grouping and aggregation, previously, even if you had an index that is covering the query, we used to fetch all the data from the index to the query, do the grouping and aggregation. Now we said, well, let's not do that. Let's do the grouping and aggregation when possible within the index itself. That's the basic idea, right? So here's the example. In the first query, you simply have the grouping, no aggregation. In the second query, you simply have the aggregation. In the third query, you have grouping and aggregation as well. Here's a little bit more complicated query where you have many number of aggregates, many groupings, and so forth. So all these can exploit index when the index is covered. Let's look at the most important part. So what we do is, this is the query processing pipeline. It goes from parse until projection. When you have an index that is covering, right, we avoid getting to the data service. You do the scan, get all the data, and do the post-processing. What we have done with the grouping and aggregation pushdown is, we have the indexer, because the index has the data organized in the right order of the keys, it can do the grouping and aggregation efficiently, right? It can because it's easier to do the grouping and the order set of data than not. So because index does this, and also we minimize the amount of data that is transferred. Once you group it, you can have 1 million documents. You could have only 10 or 100 groups. You only had to transfer minimal amount of data. Because of that, we skip over all the different filtering, pre-aggregate, and aggregate and sort operations. So it becomes much faster. Here is an example of the performance improvement you'll see. This is a simple example from TPCDS query. The latency of this query used to be 21 seconds in 5.0. Now it is under a second, 30x improvement right there. Throughput is even better, from 2 queries per second to 40x queries. Here is a little bit more complicated query. This used to take 65 milliseconds, and it comes down to, it used to take 185 milliseconds, now it is 65 milliseconds. But the effect on throughput is much higher, because remember, we avoided transfer of a lot of intermediate data between the index and query. Okay, last feature I'm going to mention, index partitioning, right? So our data was partitioned by hash automatically in the cluster. You all know that. Indexer was a global indexer. It's organized differently. And if you had to partition the index, you had to manually put a where clause, and then you partition the index, where type equals customer, state equals CA, or whatever, right? Manual partitioning means your query writing became a little bit more complicated. What we have done is, index, you can define the index and simply say hash by some either document key or something else, right? So the query engine knows this index is partitioned, and it will do the parallel scan and get the results for you. So by having we have brought this distributed automatic distribution of the index. We have brought the automatic. You had the automatic distribution of the data in the data service. The same thing applies to the index. You can automatically distribute the index just by providing the hash. We do the parallel, not only parallel scans, parallel aggregates. Remember, I talked about grouping and aggregation. Performance improvement. You get that benefit with the additional benefit with partitioning and grouping and aggregation as well. So that's the last slide. There are a lot of information on what we have done with the 5.5. Pick up your book. Thanks a lot. I'll be around in the back or after later on if you have any questions. Thank you.